Edson Zegarra for you now. He's flown in from Berlin. He works for a digital bank called Solaris. Forgive me, he'll no doubt explain exactly who he is and what he does, but he's a digital bank, European-based digital bank, which covers Europe, called Solaris. So I'm intrigued to hear exactly what that is. He's talking about serverless functions, and I'd like you to give a GopherCon UK warm welcome to Edson Zegarra. Thank you, Edson.
Thank you. Hello everyone. My name is Edson. I work at Solaris. I'm a staff engineer over there. So it's Solaris, not the operating system, by the way. If you come from Poland, you might know that there's also some bus maker called Solaris. Not that one either. There's also some sunglasses in Germany. Brand, but that's not either. So Solaris is a banking as a service platform. So basically we have a full banking license and we provide financial services, or what they call embedded finances. So if you have some product and you want to offer some payment solution or lending products related, payment and installment payments, sort of thing, and you can integrate with Solaris, which is a B2B business model. So today, that's kind of the agenda we're going through today. Just to be everyone on the same page, what was my motivation? So I was running some function in a cloud provider, AWS in particular, and it was behaving kind of weird. I was like, okay, why is that? So that's what really took me to make this presentation, and yeah, we're going to go through that. Just a bit disclaimer, I'll be using a lot of the word function, and function can refer to a couple of things, like a Go function, like the ones we usually use. Function as a general concept for serverless computing. Google calls this product GCP functions, so and there's a bunch of other similar products which also have the function name in between. So just to be clear. So let's first do some serverless 101. What are the key features? So first thing, it's a managed computing environment. So we have to deal with that. If you're going to go serverless, you have to accept that there's some management going on for you behind the scenes. And there's also this is kind of a buzzword, right? Serverless. I was running into some of you asking me or telling me, yeah, but I don't really, why is it called serverless? Does it run on thin air? There's a real server behind, right? Somewhere in some cloud. So, I mean, what's the cloud? It's not, it's just a buzzword. So I really like more the function as a service term for describing this managed computing environment, because that's what it is, right? You have you are expected to have self-contained logic in there, very specific task running for you. So I just want to point that out because serverless is kind of a buzzword nowadays. So you can focus on your actual business logic and not on managing the infrastructure. It's super scalable, like really. And basically you pay for what you use. And that's kind of the cost part. I'm not really going to talk about that, but keep that in mind. So there's some common scenarios, like why would you choose going to this kind of computing model? So if you have some uneven load, or you have some event-driven applications, some batch processing, some monitoring going on. So for instance, financial world is not really known for being such edge tech industry. So we have to deal with central banks, with taxes agencies, so government agencies, which are not, sometimes they're using COBOL or weird things. So they send you files through an SFTP. So, classic usage is you just fetch a file at whatever time they just want to, and then you just run your process. So you can think, why should I have a long-running container waiting for a file? Or why should I be polling to this SFTP? It's the watchdog. So you just have to accept the file and process it whenever it comes. So yeah, you can do some batch processing on this file at some random time. So this is going to be executed only once a day, for sure. So it makes sense to have this kind of model in this scenario. So usual setup. It's either triggered by some event or by some HTTP request. Usually put it behind an API gateway, which is the one actually listening for the request. And this is the one calling the environment to boot up your instance and actually run your code. Something very common as well, some scheduled task, kind of a cron job. Yeah. So that's big idea, really not really trying to convince you to go serverless. I'm just telling you there are some use cases which is pretty useful, so don't just go trend and use it just because. But come up with a very good common use case and use it. And take advantage that you are paying for what you use. So if that really makes sense for your use case, then go for it. I want to really quick tell you about some success story about this. So there's this pragmatic engineering newsletter that I follow. I was reported back in June, I think. There's this app called Kara, which managed to scale pretty well. It went trendy on the social media. So they were having around 100K users and went to scale 3 times only in 2 days, and then 200K in 2 more days. So basically, you could handle pretty well a load 5 times in less than 1 week. And when you're in a traditional environment, you actually have to, plan and think about that if you're able to, going to be able to handle such a load. If you're not running out of database connections, if you're not having some memory leak going on, your system works with some 100 users, thousands of users, let's say. But when you're scaling, maybe something leaked around, so you never know. Yeah, but it has its downsides, So it was a bit expensive, so almost 100K a bill, only for that. So if you have a good business model, you can pay that, then good for you. But if you don't, which was the case, these guys were funded just like buy me a coffee thingy. So, you can pay 100K with some coffees, maybe, I don't know. We have to ask them. Anyways, serverless is cool, yeah. You can do pretty cool stuff, but has its own challenges. So let's deal with that. And that's like the main point today. So we're going to do some comparison and how different providers deal with the different things that come up. I'm going to be talking about, oh, sorry about that, doesn't look well there. It's about Amazon and Google, 2 major providers on the cloud. Most of the market share is both of them. Just a bit of a disclaimer. I use a lot of AWS technologies at daily job, and I run side projects on the Google Cloud, just because. So quite a few things. First, runtime. There's no dedicated runtime for Go when you are talking about AWS Lambdas. And I mean, at the beginning, I feel that was more natural. We're going to see why. However, on GCP, you have dedicated runtimes. So usually, you have 1 dedicated runtime per language, like Java, JavaScript, Python, Ruby, and so on. But it's not the case for Amazon. Something very curious to me was the timeouts. So you have up to 15 minutes in Amazon. And on Google, you have something similar depending on the type of function that you're running. Let's stay with 10 minutes, just for the sake of comparison. So you can actually do a lot of things in 10 minutes. It's Go, and you have 10 minutes to do some computing. So if you're talking about, let's say, some API gateway and you're having some request, your user is not going to wait 10 minutes for a response, right? But if you're doing some asynchronous processing, as I was telling you, some processing of file, huge file maybe, then yeah, makes sense to have some time window to process it. So depends on what you are doing, right? That you might need that. I still think it's a lot, even for processing huge chunks of data. So let's now get into some. Oh wait, I missed that. Yeah. That's kind of how it looks, the signature for Lambda. So you have, they call it a handler. You have a function which can be of those types. Bless you. They have plenty of other signatures. I'm just showing a bunch of those. This T type there, it has to be a compatible type with the encoding the JSON package event, so they can, marshal or unmarshal events or requests. So it's quite generic. On the other hand, on Google, you have only these two signature types. And the weird thing is that you don't have a main package. That's one of the first things that when I was doing this, I was like, you just start your coding, and then you just have a main. But in Google, you cannot do that. We'll just throw you some error. We're like, OK. And then you go to documentation, and it tells you, yeah, you don't have to, you shouldn't have a main package. Sure, OK. But you also have to initialize your handler from the init function. We're going to talk a bit about this function, special function. And they have also a bunch of requirements, like your function must be at the root of the project, entry point has to be specified when deploying. And it's, I just want a simple program, like a standard program. Why should I, stick to these weird conventions? Yeah, whatever. And we have these two signatures here that you have to comply with, either both of them. First one, if it's behind an HTTP, an API gateway, and the other one's for events. And this event package, this event type there, you can see it's coming from the SDK of Google. But that's generally speaking. So let's get into some sample code. So that's kind of how it looks. Line 11, just importing the SDK. Notice that I'm using some global variables here. So I'm just setting a logger. Oops, I don't know why it's not working. OK, so I have a function which is just getting the logger. I'm using this once package for those who are not very familiar with the once package. This is guaranteeing that this is going to be executed only once. So if you call the getLogger function multiple times, this is only going to be executed the first time, the block between lines 18 and 23. And then the second time onwards, this is not going to be executed, so you just return the logger. So you guarantee that on the first time, you initialize it somehow. So this is called lazy initialization. It's quite a common pattern around. What I'm doing here, I'm just setting a prefix on line 20. As you can see, I'm setting, just calling it my app. I'm prefixing it with the timestamp of the execution time, adding some flags, and then just printing it out, like, yeah, logger initialized. Nothing special. OK. Now comes the handler. So handler is just, all right, I'm setting my logger. I'm just logging some stuff. Then I'm doing some processing. Let's say it takes 2 seconds. I'm processing. Yeah, sure. And this is my main. So as you can see, this program here, oops. Yeah. Yeah, that's 100. I'm not sure if you got that in what I was talking. Anyways, so you get the logger, print some stuff. I'm simulating some processing 2 seconds, and then you get to the main. So that's very standard Go, right? So besides the fact that you're using the SDK of Amazon, of AWS, that's very straightforward, right? So what we should see here is one login here, setting up the app. I think the previous one, oh yeah, first logger initialize because you're calling this get logger. Then setting up the app and then processing. So 3 lines, right? Not a big deal. Let's check it out with how it looks on the GCP side. So you have this package. So first thing, as I was telling you, you cannot name it main. So it has to be something else. Yeah, you just import the, oh, what did I do? OK. You just import the SDK, and then you initialize it like that. And that's the other thing, right? Which doesn't sound very natural. Where's your main? Why do I have to use the init function? And I know there are some strong opinions against the init function, but it's fine. I mean, it's a Go feature. We can use it. And you have to register there. If you don't register, it just doesn't work. So, there's this additional cognitive load that we're putting on the program to know. Besides the fact that when you call the program, the function, you have to tell which handler you have to use. But this is the same program. So they both should behave the same, different providers, but behave the same. Or at least they should. Shortly before going to the execution, let me tell you a bit about the init function. So it's a Go feature executed. They are executed just before the main in the Go runtime. So Jesus' talk was very informational about that, so you can check it out. So you don't have to call them. If you call them, you're going to get some compiler error. Initialization process is sequential. So this is important to know because if you are going to use init to initialize some of your stuff, yeah, it's important that you know what are the effects of the function. So it's initialized. So there's a certain order. First, you initialize the imported packages. Then the package variables are initialized. Then init functions themselves are called. And then main begins. But that's under a regular environment. So when I was running this on my computer, my local, let's say the server full version, I was getting that, as expected. Second execution, I'm getting this as well. So nothing special. Just notice that the timestamps, which are prefixed there, are different. However, when I go to Lambda, and I was running this twice, sequentially, I got this. So first time I get 3 outputs, as expected. But second run, I get only 2 outputs and the same suffix. So you can see here. And this is kind of what puzzled me. I was like, OK, why? I actually did not inject the timestamp on my logs. It was something else. I don't remember what exactly. But it was some value from a previous execution. And you can replicate this very easily. It's not an edge case, So you just run it once, and then you just hit the arrow key, and then you just hit enter. And I mean, there's really no big effort on trying to replicate this. So it's not I was doing it super fast or scripting it so to make it fail. Nothing like that. It's just standard procedure. On the other hand, GCP behaved as I was expecting. So 3 outputs per execution and different timestamps. Great. So why is that? So there's this issue on, or yeah, I don't know if to call it an issue, but characteristic, let's say, on the serverless world, or function as a service, which is the global scope. So global variables may or may not be reused between different runs. That's a very basic thing. Since I was putting my logger and I was putting my once object into the global scope, they were being reused for the first provider. So that's what was happening. And this is done just to reduce the cold start. Cold start is the time it takes to your instance to be ready for executing your actual code. You know? Because remember, as I was telling you, this is a managed service. And this, you have to deal with that. And they are managing so you can scale. So if there's a huge load coming in, they have to know, somehow your provider has to know how many instances to throw at you. It has to know if something went bad and then put another one on top. So this is part of the managed part that I was telling you that we have to live with if you are going to use this kind of solution. So there's different behaviors by default. It's not that Google doesn't behave like that. You can just tweak a bit on the settings, and you can make it behave similarly. You can just increase the concurrency. By default, GCP is not enabling that. So it's just single concurrent requests on single function instance. So they are just throwing 2 instances. If, let's say you throw 2 requests, it's just 2 instances. But 2 instances requires more time. And this is what I was. I want to have a closer look here. What happens on runtime on the provider most of the times? So first thing they do is just they fetch your code, your image, depends on what you're doing. Generally speaking, right? And then they have to boot this execution environment. And this second step is probably one of the most expensive, because I was telling you the things that we do not see behind the scenes. They are monitoring your instance so they can scale appropriately. So they are also gathering some metrics. They gave you some metrics for free, let's say. So everything is there. And this is quite important, because if you have a latency-sensitive application, these 2 first steps, they could take up to 1 or 2 seconds. And that's a lot, depending on what you're doing, right? And then you initialize your function. This is basically the init function just running. The yellow means that it's actually our code. The blue means that it's a provider doing something. And then finally, you run your code. So these are, again, generally speaking, this is happening in a similar fashion in both providers. But you have to be aware, not only because it might not behave the same the way you expect it, or like the regular server full version, but also it could be a bit slower. You might be wondering, why is it not closing? I mean, if we're setting some objects on the global scope, the reach goes beyond a single execution, and you can notice that somehow in your code. I noticed it in the loggers, but we'll see that you can notice it somewhere else. Some of you, if you go through the AWS documentation, Lambda documentation, this is one of the tricks or recommendations they tell you to do. Let's say you initialize a bunch of objects that you might need along your multiple executions. So this is some S3 bucket. You initialize it, and then you fetch that. So it's available for all your executions. Google has a similar thing, a similar take. They're doing this lazy global loading, putting some client. This is storage client, which I think it's kind of S3 similar. And they're putting it so it's so the scope goes beyond a single execution. And this is also on the tips and trick part of their documentation, right? How to improve, how to optimize things. And some of you might be like, yeah, I mean, I've talking with some colleagues. They were like, yeah, it might be not. Like, up to you. Just be aware that this is how they're using the init function and this global scope to reduce cold starts. Because cold starts are an issue, again, if you're latency sensitive. So someone might say, yeah, effective Go says that literally init function, it's to set up whatever state is required. However, in this world, we are seeing that cloud providers suggest its usage to help reducing cold starts. So it's they tell you, yeah, write the stateless functions. But this is not really, right? And this is something else I noticed. I was running some tests, and then how does your dependency look at it? So let's say you put a database connection, a database client connection on a shared, on the global scope. So whatever, however you're monitoring the database, it might look like the connections are still alive while there's no instance running. It's just because the provider is keeping it alive, all right? And you might be thinking, hey, there's a leak there because there's nothing running. Or there would be in this short time window, it was just nothing. But connection was up there, so how is this happening? Yeah, it's because the provider is keeping it warm for you, and it's not closing it. Yeah, so use it at your own discretion. So this, you remember the initialized block was before yellow, but to reduce the cold start, you can make it turn blue, right? So it's now warmed up and ready to be used, so you can now focus on your code. Again, it's a trade-off, whatever you feel more like doing here. That's why I was telling you, I'm not really trying to convince you to go serverless. I'm just telling you the facts, stating how they are, and you have to deal with that, right? If it makes sense for you, then go for it. That was the main part that I wanted to understand and to see how it works. There's a bunch of other platforms, function as a service platforms out there, like OpenWhisk from Apache. The Cloud Native Computing Foundation has a bunch of projects as well on this same topic. Most of them take the same approach in the Go, for the Go runtime. Most of them define some runtime for Go, and they ask you to use the init function in this particular way. I was also having a quick look on the most start projects on GitHub on Go, and the use of the init function. It's used for fetching some environment variable and setting the debug level or some configurations, even initializing some metrics for your whole service. So it's a different usage, right? Just again, you just have to live with that. Let's quickly talk about the memory limits. I was telling you, this is a managed service, right? So what happens if I get some nice file from this SFTP server that I was telling you about? Oh, by the way, all the instances I was trying on, they are basic instances. So there's no special optimization I made on either of the providers. So it's just, you just create it and that's it. So, but there's a bunch of things you can do to optimize and blah, 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 but I'm not going to that direction. Yeah, so coming back. You have this SFTP file that you're reading, and you have to process it, as I was telling you. Yeah, and then you have this, and then let's say it's a CSV file, and then you read it into a buffer, and then you start the processing. That works, right? But suddenly one day, it just breaks. And you are like, why? It was working before. Could it be some format thing? And then you go check the file, and it looks good. And then you're like, OK, it's not the format. It's not a corrupt file. So what's happening here? I'm just highlighting those lines because those are the ones which are actually going to be executed, and the other ones are not going to be even reach the 10th downwards. When you invoke it as for Amazon, you get even a 200. I'm saving here the response on some JSON file, but you get this runtime error, exit error, in this case, I was trying with some nice small files, and then I think that the instance had only 128 megabytes, and then I went for a huge CSV file, like let's say 300 megabytes, which is perfectly feasible in some application. And then with the big file, it was just dying like this. And if you see here the screenshot of the logs, it's really not very easy to understand. It's a huge stack trace, and it was loading me with 329 lines of logs. Yeah, small there, you can see runtime out of memory, but still, it's not like the best, way of managing this, because you're just polluting your logs, and you know how it gets when you have tons of logs crowded and with garbage, and you have to find out the exact line where you are actually knowing what's happening. Yeah, and also the confusing part is this here, right? You invoke it, and yeah, 200, all good, man, but not really. On the other hand, when you do the same on Google Cloud, you actually get a 503 server error. Yeah, service unavailable. And then you get that nice output, memory limit exceeded, which is cool. And then you don't have all that stack trace, which is literally not helping me at all. So this is one of the things. Again, you have to deal with your provider. This is something that actually happened. We just had a regular load. We are expecting some, don't remember exact numbers, but let's say we're expecting 300 megabyte files. And then someday there's a peak. And then this is a reconciliation file, which comes after a few hours. And then this reconciliation file is double the size. And our instances are quite small. You're paying for memory, you're paying for CPU usage time, so you don't want to just set a huge amount of memory. And then it breaks. And if this is happening, I don't know, at midnight or 2 a.m. in the morning, you're only going to notice probably next day, and then it's going to delay some processes and so on and so forth. If you have an on-call rotation, on-call rotation for a file which is processed at 1 a.m. in the morning, you don't really want to go through those logs and figure out what's happening. Yeah. Getting almost to the final. File descriptors. This is another error we had also. Production. This is a very small one. So documentation says there's a hard limit on lambdas on 1,024 files, open files. On GCP, I actually couldn't find the documentation, so I was running some tests. I asked ChatGPT, and ChatGPT said it's about 1,000. And then I asked, so can you send me the link? And it said, sorry, I don't know. I just think it's 1,000. Anyways. Yeah. So I had to do some testing there. And in this case, both providers are behaving pretty nice, and then you just get this error, too many open files. And this is particularly, when you look from this side, the way I'm presenting it is I'm doing some code, I'm creating some code to make it fail on purpose. But when it's the other way around, when you have a working code in production that fails, and you get this error, too many open files, you're like, why? I'm not even opening files on my service. My function is not opening files. How come I'm getting this error? Yeah, because it's not actual files, it's file descriptors, you know? So it includes sockets, it includes, I don't know, pipe files if you're using them for some reason, and so quite a bunch of things. And then if you're somehow, I think we were leaking some HTTP connection. And then if you're leaking that in a regular environment, you probably won't notice, because regular environments, I guess they have, by default, 64K on the limit on file descriptors, if I'm not mistaken. So if you're leaking a few thousands, you won't even notice on a regular environment. But in here, which is very much limited, you will notice. And then some bug, some leak that was on a regular container is just showing up here, right? So you just have to be careful. And since you're sharing this on the global scope, you know, it can get tricky sometimes. There's one final thing on this topic. Oh yeah, right, remember. So let's say you're running your function, which is connected to some database, and then there's a peak. So the provider is just going to give you more instances as you need. Of course, you can set the max number of instances, but many times you just forget about that. So the question is your database or your, you know, whatever dependency you have, is it ready to handle your, you know, thousands of new instances running by like provided by your cloud provider? You know, sometimes or many times people forget about that. It's just that it's working and should handle the load. And the problem is not on the function, but on the dependencies. Like the database is not big enough. You know, you have a small number of connection limit, whatever. So that also happens. So let me finish with this. Serverless functions may not behave the same as their serverful. Yeah, I agree, it's not a nice word, so function as a service is better. So they may behave as this, the usual, the standard counterpart. Consider cold start. It's something we have to consider when dealing with this. Careful on global states. Pay attention to the details of your provider, because they don't behave the same, even for same issues. Write the serverless functions. And I didn't talk about the costs, but just be super careful about that, because enabling certain features will just hit your pocket if you are not careful. There's a couple of more things. Both providers, they offer you this temporary file system /temp, which happens to be the same. It may not be temporary. So you could find some files from previous executions or even parallel executions in this temp directory. Concurrency, it's also not the same, kind of similar thing with as with file descriptors. So you have a limit, according to the docs on AWS, it's about 1024. Same, I couldn't find any reference on Google. Maybe I just missed it. I just didn't have the time to run some tests to test how many Go routines I can span on one another and see which errors I get. And one final remark, I think there's no standard naming for many things in this world. Like Amazon is calling the execution environment, and Google is a function instance. But it's basically referring to this the environment where the functions are running, right? So it can, especially if you are running on a multi-provider setup, it can be tricky, you know. Usually you want to have your infrastructure in some repository, like, I don't know, using Terraform maybe, and then, you know, the naming doesn't really match. They just try to match it to the provider, and it just adds complexity. And I think it's really not optimal. Thank you. You have a nice golf over there, by the way.
Okay. Thank you for a great talk. I have a question. Is it possible to set any callback just before provider decide to shut down our runtime, for example, to gracefully close the global client connection?
Not that I'm aware. However, they add some. Each one has its own set of metrics on their functions, so you would have to check if that's possible. I mean, if it's managed, so most likely not, but I would double check the documentation.
Thank you.
Yeah, thank you.